Argonium, an ion combining a proton and an argon atom, and so also called protonated argon, ARH+, can be made in an electric discharge, and was the first noble gas molecular ion to be found in interstellar space. Properties. Argonium is isoelectronic with hydrogen chloride. Its dipole moment is 2.18 d for the ground state. The binding energy is 369 kJ mol-1, 2.9 electron volts. This is smaller than that of H+3 and many other protonated species, but more than that of H+2. Lifetimes of different vibrational states vary with isotope and become shorter for the more rapid high-energy vibrations. For ARH plus V equals 1 2.28, V equals 2 1.2, V equals 3 0.85, V equals 4 0.64, V equals 5 0.46 milliseconds. For ARD plus 9.09, 4.71, 3.27, 2.55, 2.11 msthe force constant in the bond is calculated at 3.88 m dyne, a 2. Reactions. ARH plus H2R plus H plus 3 ARH plus CR plus CH plus ARH plus NR plus NH plus ARH plus OR plus O plus ARH plus COR plus COH plus, but the reverse reaction happens. R plus H plus 2 ARH plus H R plus H plus 3 asterisk ARH plus H2R plus H2 has a cross-section of 10-18 square meters for low energy. It seriously drops off for energies over 100 electron volts. R plus H plus 2 has a cross-sectional area of 6 times 10-19 square meters for low energy H plus 2, but when the energy exceeds 10 electron volts yield reduces, and more R plus and H2 is produced instead. R plus H plus 3 has a maximum yield of ARH plus for energies between 0.75 and 1 electron volt with a cross-section of 5 times 10-20 square meters. 0.6 electron volts is needed to make the reaction proceed forward. Over 4 electron volts more R plus and H starts to appear. Argonium is also produced from R plus ions produced by cosmic rays and X-rays from neutral argon. R plus H2 asterisk ARH plus H 1.49 F and ARH plus encounters an electron. Dissociative recombination can occur, but it is extremely slow for lower energy electrons, allowing ARH plus to survive for a much longer time than many other similar protonated cations. ARH plus E minus R plus H because ionization potential of argon atoms is lower than that of the hydrogen molecule, in contrast to that of helium or neon. The argon ion reacts with molecular hydrogen, but for helium and neon ions, they will strip an electron from a hydrogen molecule. R plus H2 ARH plus H Na plus H2 Na plus H plus H dissociative charge transfer. He plus H2 He plus H plus H. Spectrum. Artificial ARH plus made from earthly argon contains mostly the isotope 40R rather than the cosmically abundant 36R. Artificially it is made by an electric discharge through an argon-hydrogen mixture. Brault and Davis were the first to detect the molecule using infrared spectroscopy to observe vibration-rotation bands. The UV spectrum has 2 absorption points resulting in the ion breaking up. The 11.2 electron volts conversion to the B1 pi state has a low dipole and so does not absorb much. A 15.8 electron volts to a repulsive A1 sigma plus state is at a shorter wavelength than the Lyman limit, and so there are very few photons around to do this in space. Natural occurrence. ARH plus occurs in interstellar diffuse atomic hydrogen gas. For argonium to form, the fraction of molecular hydrogen H2 must be in the range 0.0001 to 0.001. Different molecular ions form in correlation with different concentrations of H2. Argonium is detected by its absorption lines at 617.525 GHz, J equals 1 to 0, and 1234.602 GHz, J equals 2 to 1. These lines are due to the isotopolog 36 argon monohydride plus undergoing rotational transitions. The lines have been detected in the direction of the galactic center SGRB2-M and SGRB2-N, G34.26 plus 0.15, W31C, G10.62 to 0.39, W49N, and W51E. However, where absorption lines are observed, argonium is not likely to be in the microwave source, but instead in the gas in front of it. Emission lines are found in the Crab Nebula. In the Crab Nebula ARH+ occurs in several spots revealed by emission lines. The strongest place is in the southern filament. This is also the place with the strongest concentration of R+ and R2+ ions. The column density of ARH+ in the Crab Nebula is between 1012 and 1013 atoms per square centimeter. Possible the energy required to excite the ions so that then can emit comes from collisions with electrons or hydrogen molecules. Towards the Milky Way center, the column density of ARH+ is around 2 times 1013 cm-2. Two isotopologues of argonium 36 ARH+ and 38 ARH+ are known to be in a distant unnamed galaxy with Z equals 0.88582, 7.5 billion light-years away, which is on the line of sight to the Blazar PKS 1830-211. Electron neutralization and destruction of argonium outcompletes the formation rate in space if the H2 concentration is below 1 in 10⁻⁴. History. Using the McMath Solar Fourier Transform Spectrometer at Kitt Peak National Observatory, James W. Brault and Sumner P. Davis observed ARH+ vibration rotation infrared lines for the first time. J. W. C. Johns also observed the infrared spectrum. Use. Argon facilitates the reaction of tritium T2 with double bonds in fatty acids by forming an Art+ tritium-argonium intermediate. When gold is sputtered with an argon-hydrogen plasma, the actual displacement of gold is done by ARH+. Other things. Argonium is the name of a major tectonic scarp on the edge of the Rhea Silvia impact basin in the quadrangle AB12 sextilia on 4 Vesta. Argonium is often an erroneous name for argon. References.